Human Y-chromosome DNA haplogroup E-M215, also referred to in the literature by other names such as E1b1b and E3b, is a major Y-chromosome haplogroup. It is a division of the macrohaplogroup E-M96, which is defined by the single-nucleotide polymorphism mutation M215. In other words, it is one of the major patrilineal lineages of humanity, linking from father to son back to a common male line ancestor. It is a subject of discussion and study in genetics as well as genetic genealogy, archaeology, and historical linguistics. EM215 has two ancient branches that contain all known modern EM215, EM35, and EM281 subclades. Of the latter two, the only branch that has been confirmed in a native population outside of Ethiopia is EM35. EM35 in turn has two known branches, haplogroup EV68 and haplogroup EZ827, which contain by far the majority of all modern EM215 men. EV68 and EV257 have been found in highest numbers in North Africa and the Horn of Africa, but also in lower numbers in parts of the Middle East and Europe, and in isolated populations of southern Africa. Origins. The origins of EM215 were dated by Cruciani in 2007 to about 22,400 years ago in the Horn of Africa. EM35 was dated by Battini in 2015 to between 15,400 and 20,500 years ago. In June 2015, Trombetta et al. Reported a previously unappreciated large difference in the age between haplogroup EM215 and its subhaplogroup EM35. All major sub-branches of EM35 are thought to have originated in the same general area as the parent clade, in North Africa, the Horn of Africa, or nearby areas of the Near East. Some branches of EM35 are assumed to have left Africa thousands of years ago, whereas others may have arrived from the Near East. For example, Underhill associates the spread of the haplogroup with the Neolithic Revolution, believing that the structure and regional pattern of EM35 subclades potentially give reagents with which to infer specific episodes of population histories associated with the Neolithic agricultural expansion. Battaglia et al. Also estimate that EM78 has been in Europe longer than 10,000 years. Accordingly, human remains excavated in a Spanish funeral cave dating from approximately 7,000 years ago were shown to be in this haplogroup. Two more EM78 have been found in the Neolithic Sopot and Lengyel cultures too. Concerning European EM35 within this scheme, Underhill and Kivizelt have remarked that EM215 seems to represent a late Pleistocene migration from North Africa to Europe over the Sinai Peninsula in Egypt. While this proposal remains uncontested, it has more recently been proposed by Trombetta et al. That there is also evidence for additional migration of EM215 carrying men directly from Africa to southwestern Europe via maritime route distribution. In Africa, EM215 is distributed in highest frequencies in the Horn of Africa and North Africa, whence it has in recent millennia expanded as far south as South Africa and northwards into Western Asia and Europe. Almost all EM215 men are also in EM35. In 2004, M215 was found to be older than M35 when individuals were found who have the M215 mutation, but do not have M35 mutation. In 2013, one individual in Khorasan, northeast Iran, was found by Pdeitiker al. to be positive for M215 but negative for M35. E-M215 and E-M35 are quite common among Afroasiatic speakers. The linguistic group and carriers of the E-M35 lineage have a high probability to have arisen and dispersed together from the Afroasiatic Heimat. Amongst populations with an Afroasiatic speaking history, a significant proportion of Jewish male lineages are E-M35. Haplogroup E-M215, which accounts for approximately 18% to 20% of Ashkenazi and 8.6% to 30% of Sephardi Y-chromosomes, appears to be one of the major founding lineages of the Jewish population. The following table only includes sample populations with more than 1% EM215 men with all known subclades as of June 2015, including the Riestland clade, which was defined by Pdeitiker al. 2015 and includes all the sub-Saharan haplogroups reported as EM35 basal clades in a previous phylogeny. Subclades of EM215. Family tree. The following phylogenetic tree is based on the YCC 2008 tree and subsequent published research as summarized by ISOGG. It includes all known subclades as of June 2015. EM215 EM215 *. Rare and non-existent. EM35 EV68 EV2009. Found in individuals in Sardinia and Morocco. EM78, North Africa, Horn of Africa, West Asia, Europe. EM78 EV1477. Found in Tunisian Jews. EV1083. EV1083 *. Found only in Eritrea and Sardinia. EV22 EV1129 EV12 EV12 EV32 EV264 EV259. Found in North Cameroon. EM81 EPF2546 EPF2546 ECTS12227 EMZ11 EMZ12 EA929 EZ5009 EZ5009 EZ5013 EZ5013 EMZ16 EPF6794 EPF6794 EL351 EZ830 E1b1b EM123 EM34 EM84 EM136 EM290 EV23 EL791 EV1515 EV1515 and its subclades are mainly restricted to Eastern Africa. EV1515 EV1486 EV1486 EV2881 EV2881 EV92 EM293 EM293 EP72 EV3065 EV1700 EV42 EV1785 EV1785 EV6 EV16 EM281. Rare. Found in individuals in Ethiopia, Yemen and Saudi Arabia. Exceptional cases of men who are M215 positive but M35 negative have been discovered so far in 2 Amharas of Ethiopia and 1 Yemeni. At least some of these men, perhaps all, are known since early 2011 to be in a rare sibling clade to EM35, known as EV16 or EM281. The discovery of M281 was announced by Semino al. 2002, who found it in 2 Ethiopian Oromo. Pdeitiker al. 2011 found 5 more Ethiopian individuals and an equivalent SNP to M281 V16. It was in the 2011 paper that the family tree position was discovered as described above. The E-M215 derivative, E-M35, is defined by the M35 SNP. Individuals with no known subclade-defining mutations are referred to as E-M35*. As of June 2015, there is an increasingly complex tree structure which divides most men in E-M35 into 2 branches, EV68 and EZ827. The most frequently described subclades are EM78, a part of EV68, and EM81, which is a branch of EZ827. These 2 subclades represent the largest proportion of the modern EM215 population. EM78 is found over most of the range, where EM215 is found excluding southern Africa. EM81 is found mainly in North Africa. EM123 is less common but widely scattered, with significant populations in specific parts of the Horn of Africa, the Levant, Arabia, Iberia, and Anatolia. A new clade was defined by Pdeitiker et al. 2015, which originated about 12 kya in eastern Africa, where it is currently mainly distributed. This clade includes the EV42, EM293, EV92 and EV6 subclades, which were identified as EM35 basal clades in a previous phylogeny. Within EM35, there are striking parallels between 2 haplogroups, EV68 and EV257. Both contain a lineage which has been frequently observed in Africa and a group of undifferentiated chromosomes that are mostly found in southern Europe. An expansion of EM35 carriers, possibly from the Middle East as proposed by other authors, and split into 2 branches separated by the geographic barrier of the Mediterranean Sea, would explain this geographic pattern. However, the absence of EV68* and EV257* in the Middle East makes the maritime spread between northern Africa and southern Europe a more plausible hypothesis. TMRCA of the major nodes in EM215 EV68 is dominated by its longer-known subclade EM78. 3. EV68*. Individuals who are in EV68 but not EM78 have been reported in Sardinia by Pdeitiker et al. 2011, when announcing the discovery of V68. The authors noted that because EV68* was not found in the Middle Eastern samples, this appears to be evidence of maritime migration from Africa to southwestern Europe. EM78 is a commonly occurring subclade, widely distributed in North Africa, the Horn of Africa, West Asia up to Southern Asia, and all of Europe. The European distribution has a frequency peak centered in parts of the Balkans and Sicily, and declining frequencies evident toward Western, Central and Northeastern Europe. Based on genetic street variance data, Cruciani et al. 2007 suggests that EM78 originated in the region of Egypt and Libya, about 18,600 years ago. Battaglia et al. 2008 describe Egypt as a hub for the distribution of the various geographically localized EM78-related subclades, and based on archaeological data, they propose that the point of origin of EM78 may have been in a refugium which existed on the border of present-day Sudan and Egypt, near Lake Nubia, until the onset of a humid phase around 8500 BC. The northward moving rainfall belts during this period could have also spurred a rapid migration of Mesolithic foragers northwards in Africa, the Levant and ultimately onward to Asia Minor and Europe, where they each eventually differentiated into the regionally distinctive branches. Towards the south, Hassan et al. 2008 also explain evidence that some subclades of EM78, specifically EV12 and EV22, might have been brought to Sudan from North Africa after the progressive desertification of the Sahara around 6,000–8,000 years ago. And similarly, Cruciani et al. 2007 proposed that EM78 in Ethiopia, Somalia and surrounding areas back-migrated to this region from the direction of Egypt after acquiring the EM78 mutation. Recently, EM78 was dated by Tromberta et al. 2015. Between 20,300 and 14,800 years ago. Listed here are the main subclades of EM78 as of June 2015. Within the EM78 subclade, Tromberta et al. 2015 allocated most of the former EM78 * chromosomes to three new distinct branches, EV1083 *, EV1477 and EV259. The first is a paragroup sister to clades EV22 and EV13. The mutation V1477 defines a new basal branch that has been observed only in one northern African sample. Finally, a sister clade of EV12 defined by V264 includes EV65 and V259, a new lineage distributed in Central Africa. EM78, North Africa, Horn of Africa, West Asia, Europe. EM78 * found in southern Portugal, Spain and Iran. EV1477 found in Tunisian Jews. EV1083 EV1083 * found only in Eritrea and Sardinia. EV13, this is the most common subclade of EM215 found in Europe. It is especially common in the Balkans. EV22, concentrated in northeast Africa and the Near East. Peaks among the Safo. EV1129 EV12, found in Egypt, Sudan, and other places. Has an important subclade EV12 *, most common lineage among southern Egyptians. EV32, very common among Somalis, Tigray and Oromos. EV264 EV259, found in North Cameroon. EV65, associated with North Africa, but also found in Italy and Spain. EM521, not mentioned by Tromberta et al. 2015, found in two individuals in Greece by Battaglia et al. 2008 and in one individual from the eastern Alpine region of Italy by Chia et al. EZ827 in Human Genetics. EZ827 is the name of a major human Y-chromosome DNA haplogroup abundantly found in North Africa, particularly the Maghreb and to a lesser extent in Northeast Africa, the Near East and Europe. EV257 EL19, EV257 * individuals in the samples who were EV257, but not EM81. A Barana from Kenya, a Marrakesh Berber, a Corsican, a Sardinian, a Southern Spaniard and a Cantabrian, is mentioned above. Tromberta et al. 2011 proposed that the absence of EV257 in the Middle East makes the Maritime movement from northern Africa to southern Europe the most plausible hypothesis so far to explain its distribution. EM81 is the most common Y-chromosome haplogroup in North Africa, dominated by its subclade EM183. It is thought to have originated in the area of North Africa 14,200 years ago. This haplogroup reaches a mean frequency of 42% in North Africa, decreasing in frequency from approximately 80% or more in some Moroccan Berber populations, including Sahrawas, to approximately 10% to the east of this range in Egypt. Because of its prevalence among these groups and also others such as Mozabite, Middle Atlas, Kabyle and other Berber groups, it is sometimes referred to as a genetic Berber marker. Pereira et al. 2010 report high levels amongst Tuareg in two Saharan populations, 77.8% near Gorom in Burkina Faso, and 81.8% from Gossi in Mali. There was a much lower frequency of 11.1% in the vicinity of Tanut in Niger. EM81 is also quite common among Maghrebi Arabic-speaking groups. It is generally found at frequencies around 45% in coastal cities of North Africa. In this key area from Egypt to the Atlantic Ocean, Iredi et al. 2004 report a pattern of decreasing microsatellite haplotype variation from east to west, accompanied by a substantial increasing frequency at the eastern extreme of this core range. Kujanova et al. 2009 found M81 in 28.6% in El Hayaz in the Libyan desert in Egypt. Iredi et al. 2004 believe the pattern of distribution and variance to be consistent with the hypothesis of a post-Paleolithic demic diffusion for the East. The ancestral lineage of EM81 in the hypothesis could have been linked with the spread of Neolithic food-producing technologies from the Fertile Crescent via the Nile, although pastoralism rather than agriculture. EM81 may also have been carried into its currently most common region together with the form of the Proto-Afro-Asiatic language. On the basis of these possible links, the men who brought EM81 into northwestern Africa may therefore have come from Asia, or they may represent a local contribution to the North African Neolithic transition, but there is no autochthonous presence of EM81 in the Near East, indicating that M81 most likely emerged from its parent clade M35 either in North Africa, or possibly as far south as the Horn of Africa. In Europe, EM81 is widespread but rare. In the Iberian Peninsula, Spain shows an average frequency of 4.3% in the Iberian Peninsula, with frequencies reaching 9% in Galicia, 10% in western Andalusia and northwest Castile. However, this study includes 153 individuals from Mallorca, Menorca and Ibiza Islands, as well as 24 individuals from Gascony which are not in the Iberian Peninsula. Without these 177 individuals, average for Iberian Peninsula is 4.9%. It is found at comparable levels to EM78, with an average frequency of around 5%, and in some regions it is more common. Its frequencies are higher in the western half of the peninsula, with frequencies reaching 8% in Extremadura and southern Portugal, 4% to 9% in Galicia, 14% in western Andalusia and 10% in northwest Castile and 9% to 17% in Cantabria. The highest frequencies of this clade found so far in Europe were observed in the Valles Pasiegos from Cantabria, ranging from 18% to 41%. An average frequency of 8.28% has also been reported in the Spanish Canary Islands, with frequencies over 10% in the three largest islands of Tenerife, Gran Canaria and Fuerteventura. EM81 is also found in France, 2.70% overall, with frequencies surpassing 5% in Auvergne and Ile-de-France. In in Sicily, and in very much lower frequency near Lucera in continental Italy, possibly due to ancient migrations during the Islamic, Roman, and Carthaginian empires. EM81 was also found in 2013 at 5.8% in a large sample of 1,204 Sardinians. As a result of its Old World distribution, this subclade is found throughout Latin America, for example 6.1% in Cuba, 5.4% in Brazil, and among Hispanic men from California and Hawaii 2.4%. In smaller numbers, EM81 men can be found in areas in contact with North Africa, both around the Sahara in places like Sudan, and around the Mediterranean in places like Lebanon, Turkey, and amongst Sephardi Jews. There are two recognized subclades of EM81, although one is much more important than the other. Underhill 2000 found one example of EM107 in Mali. EM183 is extremely dominant within EM81. Carafei et al. 2008 first described it as a subclade of EM81. The known subclades of EM183 include EM165. Underhill et al. 2000 found one example in Middle East. EL351 found in two related participants in the EM35 phylogeny project. EZ830. This is a recently discovered subclade which has not yet been included in most haplogroup trees. EZ830 includes the confirmed subclades of EM123, EV1515, and EZ830*, and is a sibling clade to EL19. Currently, the EM35 phylogeny project recognizes 4 distinct clusters of Z830* carriers, 2 of which are exclusively Jewish in origin. The remaining 2 are significantly smaller, and include scattered individuals in Germany, Spain, Latin America, Egypt, and Ethiopia. EM123 is mostly known for its major subclade EM34, which dominates this clade. A new clade was defined by Pdeitiker et al. 2015, which originated about 12 kya in eastern Africa, where it is currently mainly distributed. This clade includes all the sub-Saharan haplogroups reported as EM35 basal clades in a previous phylogeny. EM293 is a subclade of EV1515. It was first identified by ISOGG as the second clade within EZ830. It was discovered before EZ830 being announced in Hen 2008, which associated it with the spread of pastoralism from East Africa into Southern Africa. So far, high levels have been found in specific ethnic groups in Tanzania and Southern Africa. Highest were the Datuga, Khwe, Urung, and Sandor peoples. Hen in the study also found 2 Bantu-speaking Kenyan males with the M293 mutation. Other EM215 subclades are rare in southern Africa. The authors state, without information about M293 in the Maasai, Hema, and other populations in Kenya, Sudan, and Ethiopia, we cannot pinpoint the precise geographic source of M293 with greater confidence. However, the available evidence points to present-day Tanzania as an early and important geographic locus of M293 evolution. They also say that M293 is only found in sub-Saharan Africa, indicating a separate phylogenetic history for M35.1** samples further north. EP72 appears in Carafei. Pdeitiker et al. 2011 announced that this is a subclade of EM293. Trombetta et al. 2011 announced the discovery of EV42 in 2 beta Israeli persons. It was suggested that it may be restricted to the region around Ethiopia. However, further testing by commercial DNA testing companies confirmed many positive results for this subclade in Saudi Arabia, Kuwait and one person in Portugal who has a root from Arabia. The EV6 subclade of EV1515 is defined by V6. Cruciani et al. Identified the significant presence of these lineages in Ethiopia and also some in the neighboring Somalis. Among the Ethiopian and Somali samples, the highest were 14.7% among the Amhara and 16.7% among the Wolaita. To the south, Tishkoff et al. Identified one V6 plus ban in a sample of 35 Datuga of Tanzania. And further to the north, Dugujan et al. Identified another 6 men in a sample of 93 from the Siwa Oasis, which is a Berber population. Trombetta et al. 2011 announced the discovery of EV92 in 2 Amharas. Like EV6 and EV42, it possibly only exists in the area of Ethiopia. Phylogenetics. Phylogenetic history. Prior to 2002, there were in academic literature at least 7 naming systems for the Y-chromosome phylogenetic tree. This led to considerable confusion. In 2002, the major research groups came together and formed the Y-chromosome consortium. They published a joint paper that created a single new tree that all agreed to use. Later, a group of citizen scientists with an interest in population genetics and genetic genealogy formed a working group to create an amateur tree aiming at being above all timely. The table below brings together all of these works at the point of the landmark 2002 YCC tree. This allows a researcher reviewing older published literature to quickly move between nomenclatures. Research publications. The following research teams per their publications were represented in the creation of the YCC tree. Discussion. E-M215 and E1b1b, one of the currently accepted names found in the proposals of the Y-chromosome consortium, for the clades defined by mutation M215 and M35 respectively, which can also be referred to as the M215 and EM35. The nomenclature E3b and E3b1 respectively were the YCC-defined names used to designate the same haplogroups in older literature, with the M35 branching as a separate subclade of the M215 in 2004. Prior to 2002, these haplogroups were not designated in a consistent way, and nor was the relationship to other related clades within haplogroup E and haplogroup.It. But in non-standard or older terminologies, EM215 is, for example, approximately the same as haplotype V, still used in publications such as Gerard et al.